So you're getting into tech, building things, writing code. Maybe you're just starting out, or maybe you've already shipped a few projects. Either way, you're about to encounter some fundamental ideas that shape how software is built and managed. You've probably heard the terms declarative and imperative tossed around. These words pop up in documentation, tutorials, and even job interviews. But what do they really mean for you as a developer? They sound intimidating, but they're just two ways to tell a computer what to do. Think of them as different mindsets for solving problems, each with its own strengths and trade-offs. Think of it like this. One is giving a taxi driver your destination and letting them choose the route. You trust the driver to get you there, and you don't worry about every turn along the way. The other is giving turn-by-turn directions for the whole trip. You're in control of every move, but you're also responsible for every decision, every detour, and every traffic jam. Both get you there, but the experience and risks are different. One approach can be more flexible, while the other can be more predictable or transparent depending on the situation. Understanding this difference is a real superpower in modern software. It lets you pick the right tool for the job and helps you communicate better with your team. In software, this isn't just theory. It's a daily choice for engineers. Every time you automate a task, design a system, or debug a problem, you're making decisions about how much control you want and how much you're willing to delegate. Imperative means you specify every step. Install this, then do that. You're writing out the exact instructions like a recipe that must be followed to the letter. Declarative means you describe the end state. I want a server with this software. You focus on the outcome and let the system figure out how to get there. The system figures out the steps for you. This can save time, reduce errors, and make your infrastructure more resilient to change. This impacts how easy it is to manage systems, fix bugs, and work as a team. It can affect how quickly you recover from problems and how easily you scale your solutions. We'll look at real-world examples like SQL and Kubernetes, declarative, versus bash scripts and SDKs, imperative. These aren't just abstract ideas, they show up in the tools you use every day. Mastering this helps you make better decisions and build more maintainable software. So let's dive in and see how these concepts play out in the real world and how you can use them to level up your skills. Let's break this down with a coffee analogy. Imagine you walk into your favorite coffee shop, the aroma of fresh beans in the air, and you're craving your usual morning pick-me-up. There are two ways you could go about getting your coffee, and each one tells us something important about how we give instructions, whether to people or to computers. Imperative. You walk behind the counter and tell the barista every step. Grab a cup, grind beans, pull a shot, steam milk. You're not just ordering coffee, you're directing the entire process step by step as if you're the head barista for the day. You're micromanaging the process, specifying exactly how to make your coffee. Every detail is under your control and nothing happens unless you say so. This approach leaves little room for the barista's expertise or creativity. Declarative. You just say, "I'd like a flat white, please." You trust the barista to know what that means and how to make it. You're focused on the outcome, not the process. You state the end result, and the barista figures out the steps. The details are handled behind the scenes, and you simply enjoy the finished product. That's the core difference, how versus what. Imperative is about telling how to do something, while declarative is about stating what you want done. Imperative programming is like writing a recipe. Step by step, you control everything. You're responsible for every instruction, every measurement, and every action along the way. This gives you power, but also responsibility for every detail and error. If you forget a step or make a mistake, the whole process can fall apart. If something unexpected happens, your script might break unless you plan for it. You have to anticipate every possible scenario, which can be exhausting and error-prone. Declarative systems are like ordering from a menu. You simply express your desire, and the system figures out the best way to fulfill it. You specify what you want, and the system handles the details. This frees you from worrying about the underlying mechanics or the exact sequence of steps. It abstracts away the complexity, comparing the current state to your desired state and bridging the gap. The system takes care of the transitions, so you don't have to. This often leads to code that's easier to read and less error-prone. You can focus on what matters, rather than getting bogged down in the details. The system manages state, so you don't have to. This can make your applications more robust and easier to maintain over time. That's why declarative code is often more predictable. You get consistent results, and it's easier to spot and fix problems when they arise. The distinction shapes how we build and maintain software. Understanding when to use each approach can make you a more effective developer and help you create systems that are both powerful and easy to use. Declarative tools like SQL and Kubernetes are game changers. With SQL, you don't tell the database how to fetch data, you just say what you want. For example, select name, email from users where country = Canada. The database figures out the best way to get that data. You focus on the result, not the process. This makes working with data much simpler and more productive. Kubernetes takes this further for cloud infrastructure. You don't script every container action. Instead, you write a YAML file describing your desired state. I want 3 web servers running. Kubernetes constantly works to match reality to your declaration. If a container crashes, it restarts it automatically. Change the config to 5 replicas, Kubernetes handles it. You declare the end state, and Kubernetes enforces it. This self-healing, automated approach is why Kubernetes is so powerful. Declarative tools let you manage complexity with less effort. On the imperative side, you have tools like bash scripts and SDKs. These are the classic building blocks for automating tasks, and they give you direct control over every step of the process. Whether you're managing servers, deploying code, or setting up infrastructure, these tools let you specify exactly what happens and when. Bash scripts are literal step-by-step instructions. Make a directory, change into it, initialize JIT, create a README. Each command is executed in the order you write it, making the process transparent and easy to follow, especially for simple tasks. You control every action, but you also handle every error and edge case. If something unexpected happens, it's up to you to catch it and decide what to do next. This level of control can be empowering, but it also means you're responsible for every possible outcome. Run the script twice, and it might fail unless you add checks. For example, if a directory already exists, your script could break unless you've anticipated that scenario and written code to handle it. This makes scripts brittle and harder to maintain as they grow. As your automation needs expand, scripts can become tangled and difficult to debug, especially when multiple people are involved or requirements change over time. SDKs work similarly. You call APIs in a specific order, create a security group, then a VM, then attach storage. Each step is explicit, and you're in charge of making sure everything happens in the right sequence. Each call is explicit, and you manage the sequence. This gives you the flexibility to customize workflows, but it also means you need to understand the dependencies between each step. If something fails midway, you might end up with leftover resources. For example, a failed VM creation could leave behind security groups or storage volumes that aren't cleaned up automatically. You have to write extra code for error handling and cleanup. This includes not just catching errors, but also rolling back changes or removing resources to keep your environment tidy. Imperative tools give you flexibility, but also more responsibility. You can tailor solutions to your exact needs, but you're also on the hook for making sure everything works smoothly, even as requirements evolve. They're great for custom workflows, but can get messy fast. As scripts and SDK-based automations grow, they often become harder to read, share, and maintain, especially in larger teams or complex environments. As complexity grows, so does the risk of bugs and maintenance headaches. Small mistakes can lead to big problems, and troubleshooting can become a major time sink. Declarative tools offload much of this work to the system. They let you focus on the desired outcome, rather than the exact steps to get there, reducing the burden of manual error handling and cleanup. But sometimes, imperative is the only way to get a unique job done. When you need full control or have highly specialized requirements, scripting and SDKs remain essential tools in your automation toolkit. Choosing between declarative and imperative isn't just personal preference, it's strategic. Imperative is best when you need full control, like custom data migrations or unique build processes. You can handle every edge case, but you also manage all the complexity. Declarative shines for stability and scalability, especially in infrastructure. Define the desired state and let the tool enforce it. This reduces errors and makes systems easier to understand. New team members can quickly grasp a declarative config. Changes are made by updating the declaration, not the running system. The system figures out the safest way to apply changes. This makes managing complex systems much more reliable. The paradigm you choose affects team collaboration. With imperative scripts, merging changes can be risky, order matters, and hidden dependencies cause bugs. Everyone needs to understand the whole script to avoid conflicts. Code reviews are harder, and coordination is a must. Declarative tools like Kubernetes or Terraform make teamwork smoother. Configurations are broken into logical blocks. Order usually doesn't matter. The system understands dependencies and applies changes safely. Merging code is safer and intent is clear. Team members can work independently on different parts. The tool manages state, reducing conflicts and bugs. Declarative approaches scale better for teams. Debugging is another big difference. With imperative scripts, a failure at step 5 might be caused by step 2. You have to trace the whole sequence to find the root cause. Debugging is manual and time-consuming. Declarative systems make bugs easier to spot. Problems are usually mismatches between the declared and actual state. Tools like Kubernetes or Terraform show you exactly what's wrong. You compare desired versus actual not every step. Debugging is faster and more direct. The system helps you find and fix issues. Development speed matters. For small tasks, imperative scripts feel faster. Just write and run. But as systems grow, scripts get tangled and slow you down. More features mean more defensive code and complexity. Declarative tools take more setup at first, but scale better. Once in place, adding or changing features is quick and safe. The system manages state and errors, so you focus on features. Changes are predictable, and onboarding is easier. Declarative configs serve as living documentation. For complex systems, declarative is almost always faster in the long run. It keeps your team moving forward. So what's the takeaway? Declarative and imperative are two tools for different jobs. Imperative gives you control, great for custom, hands-on tasks. Declarative lets you manage complexity at scale, ideal for infrastructure and large systems. Understanding both helps you choose the right tool for the job. It's not just theory, it's a practical skill for your career. You'll write better code, collaborate more effectively, and debug faster. Next time you hear these terms, you'll know what they mean and why they matter. Mastering both paradigms makes you a stronger engineer. You'll make smarter decisions and build more reliable systems. That's a solid foundation for any tech career. If you learned something new like the video, share your thoughts in comment section and don't forget to subscribe the channel for more related videos.